Okay, welcome to another video by Technical Technician from Diagnation. And basically the title of this video is called Honda VTC, or Variable Valve Timing. Honda VTC means for valve timing control, oil pressure, and a scope. We're going to basically look at the relationship between the VTC solenoid, which is duty cycled by the PCM, how it advances or phases the intake camshaft. It will phase it to the more advanced position as the duty cycle increases and the oil pressure goes to the chamber in the actuator to move that camshaft so its events happen earlier in the time sequence. So basically we're looking at, as you look at your illustration here, we can see the VTC solenoid. That's right where the oil comes in to the solenoid. The solenoid is duty cycled up to the intake cam actuator. And I've showed this in some other videos in the past. Basically, on this engine, on the 2.4 Honda, they phase the intake camshaft only. And that will, the movements of that cam is monitored by its cam sensor, and there's also the crank sensor. And what we have here is I removed the oil sender, which is down below, not too hard to get to. You can't see it, but it's in direction. If you would look down there, the oil filter is down there, and above the oil filter is the sending unit. You just pull the connector off, and you unscrew the sending unit. It's like a 1 1/16 socket, and then you're going to go in with some adapters. I'll show you what I went in with. Basically, we have the WPS 500 hooked to that where the sending unit came out. So we're going to monitor direct oil pressure. It's just the regular oil pressure the engine uses, and that would be on channel A. Channel B is the crank sensor. Channel C is the cam sensor, so we can see the relationship of the advancing and the retarding of the cam. And channel D is we're going to current ramp the VTC solenoid. We're not going to look at voltage, but we'll be able to determine duty cycle. But I'm more so interested in the current going to that solenoid, which really shows that it's working. So basically, we're on 4 channels, and I want to show you. This is how I was able to get to the sending unit. This is I went to Amazon, and they sell those automatic transmission pressure test kits, like $20. You get a bunch of adapters, and I screwed the gauge, the actual analog gauge from there, and I put the Foster coupler in. With the Foster coupler is threaded, I believe, 1/8 inch by 27 national pipe thread. It fit right in there. Use some Loctite or some Teflon tape, and this is the quick disconnect, which I actually was able to cut that hose, and then I put a clamp on it, and then I went to the adapter that came with the kit, and I tightened down the clamp, obviously, and that went to an adapter that comes with the kit. It looks something like this. This is what was screwed into the I'll get the specific one right here. This is the specific one which went in the Honda. I had to get that adapter right there to go into the engine, and then on the other end was that quick disconnect adapter which comes with the kit, and it's quick disconnected to here, as you can see. But be very careful in this testing sort of methodology. You'll be real careful. I did take it down the road. Everything has been scoped and recorded, and I'll show you the scope capture. But this is nothing we want to be taking a long road test. You just be careful of your routing. It's really important. And I always felt safer when the scope was on, because I could actually look at oil pressure. And if, watching that thing, if that thing ever took an abrupt a turn down, my hand is at that right on the key as quick as you can. But nonetheless, we don't want to lose oil pressure. So basically, I was in the area of the engine compartment. I did lay the WPS 500 down about right here. I was protecting of it. Always protect your equipment. I did make sure the hood was able to close, and without affecting the transducer, and then the routing of the oil hose. You be real mindful when you set this up. Don't do it hastily. Look for any rotating components to make sure they don't hit it. Any rub spots, nothing will hurt that. It's nothing you want to be doing too long. It's just when you get your scope capture, your diagnosis, and and then go with it. But it's just one of those things. Just be real mindful when you do this setup. As far as our scope, you're going to see I just want to talk about oil pressure and variable valve timing. It's real important that we check the oil pressure, or when we have a situation where we have a VVT issue. Now, of course, we wouldn't go to oil pressure immediately. Scan data is powerful. It shows us a lot of things as far as on the PIDs, as far as advanced, retard, cam position error, things like that. But just be mindful that we want to make sure oil pressure is up to snuff for even if the engine didn't have variable valve oil pressure, we know is critical, but nonetheless we want to be careful that it all starts with oil pressure as far as phasing those cams. I can't think of that Triton 3 valve by Ford. I've heard that you got to be north of 30 psi when it's idling and hot for that system to function properly. That has a myriad of different issues as far as variable valve timing and phasers and things related to timing. So always be mindful of oil pressure when we deal with a variable valve timing issue, whether it's from a performance issue or a check engine light or a code or something like that. Anyway, we will go to the scope, and let me get that looks a little blurry. Let's get to the scope. And okay, you can see the scope. All right, we have about 8 screens, and I will go through each screen. You can see the red is the cam sensor. As you took on your illustration, you wanted to take a little snapshot. If you forgot, I was my bad. Just go back, roll it back to your illustration, take a snapshot. I'll explain each channel. Red is the crank sensor. Green is the intake cam sensor right here. Yellow, that is the current going to the phaser, going to the VTC solenoid. The solenoid duty cycles and sends a certain amount of oil pressure up to the chamber in the actuator up by the cam sprocket to phase the intake cam. Channel A is the WPS 500. That is in the where the oil sender came out. That is actual oil pressure. We can see it. Let's just take a first look at our first capture. This is idling. Let me get the RPM and the pressure. RPM on this guy, we're idling and we're about let's get that RPM. Okay. Okay. I'm sorry, let's get that. Okay. Okay. Let's go 1 rev to get the software will give me the RPM. And we're about, okay, 786, as you can see in the right corner right here, we're about 786. That will probably tell us that we're idling. Let's get a baseline. We're idling right there, and let's get our timing just for the grins. Let's just see where we are as far as our timing, and we'll base everything there. I'll only make 2 timing advanced check during this whole video. We're going to concentrate on oil pressure. Here is our fire cycle, 720 degrees of rotation. And I'll base it from there to the first notch on the intake cam. Not really degrees before top to the center, but degrees of where the cam is, how far it is from that reference point on the crankshaft. See, here's our crank, here's our cam. We are 101 degrees away. That's the car is idling. If everything goes the way it should, the green cam signal will move to the left. That will happen sooner. That would be advanced that way. So we'll keep that into our brains as 101 degrees. We should be less by a certain amount of degrees once we start to phase. We look at our current on our solenoid right now. Our current is low. I'm sorry, we are not activating the VTC solenoid. We're about let's see that, about 7.7 milliamps on the solenoid. So anyway, let's get back to normal, and we can see our oil pressure at idle is okay, about 29, about 28 and change at idle, and you can see the oil pressure ascending here as I get into the throttle. Right there, it looks like it clips. That may be the relief valve. That's about 90 psi. We can see that, but nonetheless, we'll kind of analyze that more in depth as we go down the capture. Here we go. Let me get that solenoid in front so we can see it, see the action. Okay, here we got right here's a good picture where it's phasing. You can see our current going up to the on the VTC solenoid. We're starting to ramp up. How much amperage do we have there? Okay, we got almost about 615 milliamps. to get that solenoid to start to phase. Our oil pressure is high about here. Let's take a look at our timing about right here to see if if we've changed the amount of timing from as we measured it last time. Let's take a look at our fire cycle. Okay. Okay, that's 720 degrees of crank rotation, and let's see where we are here. We were 101 degrees. Okay, right here we are, okay, oh, my bad, okay. Okay, come on. Okay, we're about 89 degrees. So that's a lot less than 102 last time. So we're closer to that reference point. I'm sorry, we're closer to that reference point on the crank. So this timing was advanced. This green action on that cam sensor happened earlier, happened to the left of our capture. So that's sooner. We always think of the horizontal plane on the scope as a clock, and this is earlier and this is later to the right. So anyway, let's keep going down the line and analyze it some more. We can see our oil pressure. I will put some stretch on the oil pressure, and I will also put that in front so we can see it, the blue, and give it a little, oh boy, okay. Righty. Right there's our oil pressure. We are climbing, and obviously we can see the relationship between oil pressure as with throttle and RPM. Here we go. We can see it some more. There's our oil pressure, and our oil pressure goes up. And let's take a look at oil pressure at the moment. Okay, well, we see oil pressure going up here. We see the PCM has commanded the spool valve to open more to get more oil up to the actuator, and the oil is starting to flow into the actuator, and we can see it here. There's our oil going up, and the next capture right here, our oil going down, oil pressure going down as the RPM goes down, because variable valve timing is contingent on RPM and load. PCM decides when it wants to phase that cam. It's got control of the solenoid. So anyway, we can see there was a little action here, got a little bit here, where the PCM gave it some advance. Not for long though. And here we see some more. That's the oil pressure going up here. The phase has already been happening here. We can't really see much of a current ramp because it's a duty cycle. I will see a current ramp in another way I do is I will shoot a video soon on VTC, which is a little different. It's not duty cycle, but and again, we talk about duty cycle, and I showed that in other videos. This is kind of our duty cycle here. We really can't get a good measurement because we're looking at current. It's hard to see a pintle hump here, but nonetheless, I'm going to lose you soon. This computer's ready to go south on the battery. I'm just going to give you as much information as I possibly can while we're still going. Basically, here's our relationship is between oil pressure and duty cycle on the solenoid, RPM, crank position, and of course cam position, which is also right here, the cam position. Did we lose that? Okay, there's our cam position. So basically we see the relationship between the crank position and the cam position. The cam position is variable in green. That will go either advance to the left or go back home. When the car goes back to idle, it phases back home. It actually retards to its home position, but it's designed to phase to advance when it phases. As this duty cycle changes, this cam moves to the left, and the events of the cam lobe action on the intake cam happens sooner. So nonetheless, this technical technician signing off. Remember to be mindful of oil pressure. If you not every time you realize the scan tool is important. You don't want to have to waste a lot of time. I mean, it's if you see need to check oil pressure, definitely consider it in your diagnosis. And it is very, it's very important on any engine, but particularly when we have a variable valve timing issue. Thanks a lot. Take care.